那只有一个人呢？这只有一个人。好，他打完我刚吃饱，他刚吃饱，早上没有课不？
刚刚睡到下午起来，
那这样子，多少睡？
多少4点睡。
你现在是今天早上睡？怎么这样子？
看三个月，看 YouTube，玩下，看到4点多。
啊？
那个地狱玩家，
上
open set，
上
open set，也就是讲我不用拿完所有的 open set 了，
就是存在一个
存在一个 open set，就还有其他 open set 吗？
就是说，
在另外一个，
这句话意思是说，我可以把 C 写成R2切掉一些 open set，
其实不是所有 open set，
怎么能够切掉所有的？
我切
切掉所有或是没有东西，就是不一定没有东西啊，就是flexible 啊，对啊，比如说
R2是一个 open set，
R2是一个 open set，对啊，所有就是说 R2切 R2的 empty set 啊，
这个部分的open set 给它切掉，那我还不是在所以 R2本身就是一个 open set，所以不能切掉不能写成 open set 的意思。
什么意思啊？再讲一次。
就是不能写成 O，
没有啊，这个意思是说什么叫做 close set 在 R2嘛？只要你能够把它写成 R2切掉一些 open set 就好了，就这样。
对，
有什么？
这是我比较
你想干嘛？
比较比较 confused 是为什么不要写成 O 的话，你又讲全部都不见，也不是讲
是 O 的意思是说
连这个也要切掉，
啊，
所以就是什么都没有。
不是 for all 的意思是说都可以，什么都可以。for all 的意思是说，怎样讲？for all XPX is true 的意思是说，P 不管上什么 X 进去，它都是对的。所以，所以我可以选两种 open set 在这里面吗？然后他们又不一样的东西，就是我觉得你有一点不太理解 for all 跟 for some 的意思。知道什么叫做 for all？
所有，比如讲，如果拿这个来当例子，就是所有的 open set 都
不是一个东西可以写成所有的东西。
这种，可以这样讲。比如讲我4个就是这种
啊，
比如讲我5个 open set， 我可以拿掉4个，也是3 open set， 不是？
对
，2个也是。
对，只要一个存在就可以了。
那如果我这个 set 里面有10个，
然后
这 open set 里面有5个，我只要拿掉1个，那它就算 close set。
就是
这 这四个是怎样？这四个都是 open set
能讲啊？
啊。如果五个 open set 的，
谁？你拿掉什么一个都是一个 close set 来的
那这个时候一个都算是 close set。
嗯，然后哎，
但是其他
怎么就是一个 close 的特性吧？
对啊，都是个
在想报告可以做什么？
报告可以做吗？
有什么问题看不到？
我手办的那些都没有兴趣，
你放那里，
还没看。有啊有啊有啊，哦，不然做一个我有很兴趣啊，有一个很有兴趣，
妈，
不知道难不难，
不知道呢。
但是我觉得很实用，
关于什么？
你知道 Shopee 吗？
就
没有用过 Shopee？
啊，就币啊
Shopee 不是每次会出 voucher 吗？
啊，
然后他说要买满多少会扣多少，或者然后有时候扣又有 cap，不是？
啊，
所以你能不能 maximize 那个 profit？
你不是啊？
我不知道要不要 differentiate 啊，但
什么？
我觉得这个很有趣。
交给你了，这个主题，换一个主题。
可是啊，王也不是讲每个佛道都可以用啊，对不
对
对？
对对对对对，但是就是说哪一种，就有时候他讲扣多少就几%啊，或者 coin cashback 啊什么这样不是？但是有时候是买150扣30，或者是300扣30，这样子的话哪个 percentage 比较高？然后你150，有时候你买东西又不能凑到150哦，
啊，
然后你会多一点还是少一点啊？不要讲凑也会凑出。我觉得这个很有趣啊。
那
还是你要做什么？你要做什么方向？你喜欢什么？种榴莲？
种榴莲可以做什么？
关注那个榴莲自己。
怎样种比较多的榴莲？
对，种榴莲。
啊
第一个他
，maximize
种的就是
maximize 这个榴莲。
那个榴莲树间距要多少？
然后榴莲树之间还可以做东西。没有，你要种，你什么方向比较有兴趣？
没有方向。
应该是种榴莲。
不然你以后打算做吗？
以后打算做什么？
嗯，
企业家做什么？
企业家，企业家，企业家，还是你要不要看一下股票跟这个有没有关系？
股票蛮有兴趣的，
看黄金哇，
看一下股票跟高哥数有没有关系？
有没有？OK，
可以啊，
可以可以。
怎样
对对对
怎样你成名股
股票这
票，
个
怎样买股票，
对对对，
可以吗？
可以可以，对对对，有
你是不是会
点
低啊？
有
你是不是会这样这样？
你看得了，都是上面在，
没有可以看趋势的，
阿嘎，
上面都在那个这个不是？
确实啊，
可以大概看趋势啊，看他们买进来买出。
这样
可以，
可以
就可以打一下资料先。
，OK
不做那个股票，
OK，
你就是那个小逼啊！
都是买多少钱啊？
这个 iPad，钱
顶
啊，
对，多少？对头吧？
最大那个最小的才不是最小的那个 memory，
128，
那是60，忘记了。
那个不用卖啊，我放了这样，看一下，不用卖喂，
要一般什么？
到64够用，那个不够用的。
是哦，因为他现在他的那个 data 很大
啊，对，那是真
啊，system data
越来越够力，
越来越吃味。
是吧？
没有，上次一家被做爆去，
做爆，
iPad
很容易做爆。电话放床上跟你一起睡觉不会压烂，但是你放 iPad 一压就完了。
它的 design 不好，
嗯，
它 design 在一片。
对，很容易就压一种东西。
多号决定了哈？哎，你要换 iPad 啊？
没有啊，因为我买的是64G 的，
哦，OK，没有，你买多大？你买
我买 iPad Air
iPad Air 了啊？OK OK，买了还是什么？
买，我就用这个，
刚刚买还是？
久上个生日买，只是64哦，哎呀，好像不够用，
嗯，做到现在
虽然讲还有24G 的，
不能拍照
啊
，video。
嗯。
All right. Good afternoon to everyone. I forgot to tell you the format of the written project tool. Is you have to come up with a problem statement and then you solve it. Okay, there are two parts of it. Just problem statement, one sentence like that. Tell me what's the real life problem you need to solve, and then write down the solution using calculus theory to solve it. Does that make sense? Don't phrase your problem statement academically. Okay, phrase it as a real life problem. So just now I come out with a real life problem, right? I forget to introduce to you. It's Shopee. You guys use Shopee? Use Shopee on online purchasing apps, Taobao, something like that, Lazada. So they have this voucher system, right? They give you voucher if you buy above 150, they give you 30 ringgit or 25 ringgit, like that, right? But often you don't have enough item to buy, so you need to buy more. So they somehow like encourage you to buy more stuff, right? So how can you maximize this voucher, the profit from this voucher? Maximize maximize the discount from this voucher. You determine how do you determine, right? So this is kind of interesting, okay? So that we all can buy wisely, purchase wisely, right? Okay, there are all sorts of vouchers. So which voucher is good? Cashback voucher, percentage voucher, or discount voucher, right? Or cashback voucher. They have two types: cashback or coin back. So which one is better? And also installment. They also provide as pay later voucher for Shopee Pay Later. So installment pay. So which one is better? Right? Which voucher is better? Okay. Then when the Double 11 comes, you know which voucher to choose, right? Okay. So it's a good. I think it's a very interesting topic to try. Okay, if you can. I'm not sure what theory you're gonna use, but very interesting. Definitely need to come. Okay. See, have you tried the double integral last time? Yeah. Forgot already. Yeah. Just wake up. Okay. Before that, let's recall what we have done last time. Yeah, let's recall the double integral. Right. So, where do we do double integral? So, we have to let f xy be a function of two variables. Okay. Then we can do double integral on this function. Okay, over some domain. Let's call it R first. So firstly, how do we define this? This is by definition a doubly sum, a doubly limit on doubly sum. So which you compute the cuboid that approximate your volume under the surface. Okay. So we don't want to use the definition. So what have we introduced? Okay. So if fxy is always greater than equal to 0, okay, what does this number here compute? This just compute the volume under the surface xy and above the xy plane. Okay, so you should have a picture in your mind like this, something like this. So you have xy plane, okay, and then you have some surface on top here. Okay, you are computing the volume below this. So you have somehow you have a volume under it. Okay, let's keep it like this. Okay. Volume under the surface. Okay. If fxy is always positive. Make sense? Okay. So this has to be make sure it's always positive or non-negative. Okay. And then next thing we learn is Fubini's theorem. Fubini's. Well, what's Fubini's theorem? When is the function integrable? When can you do integration on function? Your function must be continuous. Okay, must be continuous. Except as finitely many curve is okay. Okay, but it has to be continuous. So if your f is continuous, we consider a special domain here, which is the rectangle. Okay, we consider a special domain rectangle. So call it R, which is AB cross CD. So AB here refer to the x coordinate, and then CD refer to y. Okay. So how to compute the double integral here? Anyone remember or not? How to compute this double integral? Hmm? Hmm? So you have two interval A to B, C to D. Okay, how to compute the double integral? Huh? How to change dA? Yeah, how to change dA? So where's this dA live? This dA actually live on a xy plane. Okay, so your x coordinate is from A to B, and then your y coordinate is from C to D. Okay. So how do you compute the integral? Let's say you have a surface at the top here. How do you compute it? So you can do partial integration or the iterated integration, right? So you could integrate with respect to, let's say, x first, okay? Keep your y constant. So your x is going from A to B, and then you do y from C to D. And Fubini tells you that you can commute the two. Okay, you can commute the two variable. So you can do y first, and then do x. And you will get the same answer. I guess this is what Fubini's theorems tell you. So what does this mean? So when you integrate with respect to one variable, what happens? Let's say you integrate along dx, right? Okay, what happened? So you are integrating where? Zx. You are integrating along the zx plane, right? Okay, so you fix a y. So you fix a y direction. Okay, so for example here, right? You fix a y direction. Okay, and then you integrate along this x direction. Okay, so you need to integrate above this xy plane or below, depend on your surface, right? So you will have this. Later we'll call this a curtain. Does this look like a curtain? Does this area here looks like a curtain? Yes. So you pick a line in the surface, right, and then you integrate the area below this line. Right? Does it look like a curtain to you? Curtain then, piece of curtain. right? And then you after you integrate along this x direction, you need to integrate along the y direction. So you kind of join all the pattern together to get the whole volume, right? Okay, okay, make sense or not? It's like a box, like a box. How do you make out a box? Okay, it's like a CD box. You have a box, right, to put in the CD. So you can think of it, the CD is a piece of CD. So you use the CD to fill out the box. Can or not? Does it make sense? Okay, yeah, this is how you should imagine about this. Then, how about the other direction? So in the other direction, we fix x first, okay, and then we integrate along y. Okay, we fix x, integrate along y. So I put my CD on the other direction. Okay, just now my CD is horizontal. Now my CD is vertical. Okay, make sense? Yeah, this is very important for later. You need to imagine your volume. Okay. Yeah, right. Good. Okay, let's return to our example last time. Okay, this one. So we're going to integrate y sine xy. Okay, y sine xy on this rectangle here. And y sine xy is continuous because it's a composite of continuous function. Okay, so there's two ways to compute here. Did anyone go back and try these two ways or not? No? No? Okay, if not, then we will try now. Okay, let's try now. Let's try now. Okay, try maybe we break this class into half. So from Qiao Tong to the left, you guys try number 1. And then to the right, you try number 2. Okay, see who get the answer first. See who get the answer first. Maybe Larry can produce too. Just shout out your answer if you got it. Hmm? You are using method 2, is it? Negative 9 over 8. Okay. Any other answer or not? Huh? 不会? Why? Got other answer? Roland, you done? Not yet. Anyone finish? Anyone else finish? Method 1 should be not that long. Method 1. Answer 了，精神。No? You were reading a variable integration. 半夜 You try method 1? Yeah, method 1 is 0. How about method 2? Huh? You haven't tried? 打折 First one you need to use what? You need to use integration by part. Right? You need to use integration by part, right? No need. Let's see. Which one you need? Oh, sorry, it's the second one. This one. Yeah. So method 1, you should get negative y cosine xy equal y 1 to 2 dy, right? Then you do integration. And then you get minus sign. 102 plus sign. Both should get 0. And no one finished trying method 2, is it? Method 2, you need integration by part. Then you should get 0 as well. It's probably okay. How long? How many steps you take? Five steps. Yeah, maybe you need to take 5 steps. But be careful, don't make mistake. Okay, so Fubini's theorems give you a way, okay, to compute in 2 ways, okay, at least. So maybe one is easier than the other. So in exam, you need to pick wisely, okay? Don't just delve into doing integration, okay? Otherwise, you'll make mistake. You see, one of them you need integration by part, the other you just integrate properly. That's all. Okay, so you see this integration here is 0. What does it mean? Okay, what does it mean here? So let me show you this graph here. So there's some part of this graph is positive. Okay, some of it is negative. Okay, but why this double integral is 0? Okay, what does it mean? It means that the area under the surface and above the surface, okay, they cancel out. Okay, so this surface bounded volume with the xy plane here. Okay, and then the top part and the bottom part they cancel out. Okay, now this is similar to our one variable area case, right? Did Zheng Kan prove that this cosine graph is 0? Is this cosine graph 0? The integration of this cosine graph, is this 0? 0. Sorry, cosine, right? Cosine is like this. This 0?
Yes.
Yeah. So it's similar to the bottom, one variable function case. The top area and the bottom area cancel. Okay. So you need to be careful when you compute the double integral here. So for a function that takes both positive and negative value, the double integral will represent the difference of volume. Okay. V1 minus V2. What is V1 minus V2? V1 is the volume above R and below the graph F. So what is R here? The R here should be the XY plane. Okay. And V2 is the volume below and above the graph F. Okay. So it represents the difference. So if the question asks about volume, you need to be careful when you compute the double integral. Okay or not? Which part is above, which part is below. Okay. If it is below, then you need to take minus. Okay, let's try one example here. So find the volume V of the solid under the surface Z equals to minus 4 x squared minus y and over the rectangle. Okay, this rectangle is living on the xy plane. Xy where it is bounded by 0 and 1 for x coordinate and y is bounded by 0 and 2. Okay, so what's this picture here? What's this picture here? So should we determine whether this function, this surface is always positive on this rectangle or not? Okay, so let's show that if this is greater or equal to 0, always on R. Okay, let's check this inequality here. Okay, how to check this inequality? How to check this inequality here? See, 4 taking away x squared, taking away y. Okay, and then we want to show that this value here is always greater or equal to 0. Right? So you think about it first. Try and think about it first. X is in between 0 and 1. Okay, so if you plug 0 and 1 into the square, what happens? It is still in between 0 and 1. Okay, so 4 minus 0 is greater or 4 minus 1 is greater? 0 is greater, right? But you can go down to 3, 4 minus 1. Right? Okay, you can get the value between 4 and 3. Okay, how about y here? How about y here? Y is in between 0 and 2. Okay, y is in between 0 and 2. Okay. So the most number that you can take away is 2. Okay, so 4 minus 1 minus 2 is 1. Okay, 1 is always greater or equal to 0. Okay, this is the least number you can get. Okay, so how to show this mathematically? So first, you know that x is less than or equals to 1. Then this implies that x squared is also less than or equal to 1. Okay. And then this implies what? 4 minus x squared is always greater or equals to 4 minus 1, which is 3. Make sense now? Okay, I put minus on both sides and then I add 4. Okay. And then next one. Next, so we can see that 4 minus x squared minus y actually greater or equal to 3 minus 1. Okay, which is greater or equal to what? Okay, minus 2, because y is less than or equals to 2. And then similarly, this implies minus y is greater or equal to minus 2. Okay, does it make sense? Make sense or not? Okay, so this is equal to 1, which is always greater than 2. Okay, so it is good now. What is good? Because this surface is always positive, okay, on this rectangle. So your double integral will give you the volume 1. Okay, then you can do double integral on the surface here. The volume of the solid will be represented by the double integral z dA since z is greater or equal to 0 in R. Okay, then we can do double integral here. So V equals to the double integral on z dA. Okay, so what technique we can use to solve this double integral? The domain is a rectangle. Okay, and then check this function is continuous or not. This surface continuous or not. Is it continuous? Polynomials are continuous. Okay, so we can use the Fubini's theorem. Okay, so Fubini's theorem. So you can do, let's say we fix x and then do y. Okay, so we do y first. Fix the x direction and then we integrate along y first. Okay, let's do this. So very quick. So we just get 4y minus x squared y minus y squared over 2 from 0 to 2 dx. Then you just sub the values in, which you will get altogether you get 6 minus 2x squared after simplifying. Okay, and then you integrate again. You can check my step because I will post the solution now, so you don't need to copy. And then this is 1600. Okay, so your volume is positive. Sense? Yeah. And then of course you can do the other direction, right? So you can do the other direction. So what's the other direction? You fix the y direction first, and then you integrate along the x direction. Okay, so remember this refer to how you place your CD, okay, inside your volume. Okay, you can try the other way. You should get the same answer. So this is the picture. So here your Z is this surface here, and then you try to get the volume under this surface. Okay. Yeah. So far so good. Okay. Next. Okay, no question? No question? Okay. Okay, next. Okay, so this is another technique. So if your fxy can split into the product of two functions, one singly in x, the other singly in y, then you can split your double integral into products of integral. Okay, so this example is given by this sin x cos y here. Okay, along this rectangle. Still rectangle. Remember, we start with rectangle first because this is how we use cuboid to estimate our volume. Later, we'll work with general one. Okay, so you can see that this function here, fxy, so fxy is sin x cos x. Okay, I can write it in terms of gx hy. Okay, I can split the function into solely in x and solely in y, where my gx equals to sin x and hy equals to cos y. Okay, then I can do this double integral, okay, by splitting out my integral into products in x and in y, dx and dy. Okay, cos y and sin x going from 0 to power 2, y cos y going from 0 to okay. And then what is this? What is this? So this is simply minus cos x from 0 to power 2. The other one is sin y from 0 to power 2, okay, which is 0 plus 1 times 1 minus 0, which is just 1. Okay. All right. So think about it. Why is this true? Why can I do like this? Yeah, I mean, if we don't split it, okay, if we do the usual double integral, what happens? We are also treating the other function as a constant. Okay, we just treat the other function as a constant. Right. So let's say this is dx. So we're just treating it as a constant. So we simply pull the constant out. Okay. Okay or not? So maybe I put the bracket in here, maybe you'll see more clearly what I'm doing. Okay. Yeah. Okay. So basically, I just help you to skip one, maybe 2 steps. Okay, skip this 2 steps and then do it together. You are safe to do. Before you cannot answer him. If you cannot split the function, you cannot split your integral. Okay or not? Okay. Because people tend to use this property, just split the function before. I mean, similar, but you cannot, yeah. For example, which one? Actually, people might mistaken this one. For example, this. They don't see that here there's a y. Maybe they pull the y up and then they do the 2 integral. And then somehow their answer come up with something in y. Still have a y there, cannot settle. Yeah. So please make sure you can really split your function into products of in singly variable. Only you can split the integral. Okay. Okay. So don't simply split your product. Okay. Yeah. Otherwise, your answer will left with extra y. Then you're not sure how to do. You thought it's the answer already. Okay. Yeah. So the graph is something like this. So it's positive. there's a volume 1 here below this shape. Okay. Yeah. All right. So this is a bit look like the wave. Okay, any question about this? So what we have introduced here is like technique of calculating double integral and when we treat double integral as a volume. Okay. Okay, next we'll deal with double integral over general regions. Okay, so you see the general regions here could be any shape. Okay, could be any shape. Okay, look at this island here. And this is an island. So we only know how to integrate along square, right, or rectangle. How are we gonna integrate along this island, right? How to integrate along this island? So we put this island into a rectangle C or rectangle pool column, okay, square column, okay. So this although we have, let's say we have a fxy defined on this D here. Okay, let me write. So let's say we have a fxy, okay, defined along this island here. Okay, maybe like this. Okay. So what do? I will put this island into a rectangular pool. Okay, we put it into a rectangular pool. But what happened to the height away from this island? I set it to 0. I set it to 0. Okay, so I still have this island here. Okay, but I set all the other places to 0. Okay, set all the other places to 0. Okay. Yeah, 0. Okay. Then we will say that this piecewise function f, okay, is integrable. If it is integrable, then we will define the double integral of f by, so you see, we use the big F to find the double integral of small f. Okay, it doesn't affect. Why? Because away from this island, I set the value to be 0. Okay. So the double integral of general region of small f is equals to the rectangular region of the big F. Because why? Because we know how to get or estimate the double integral over a rectangular region. That's what we did before. Okay. So we define a new integral using what we have known. Okay. We define integral on general region using the integral on rectangular region. Okay or not? Okay, why is it equal? This is non-trivial. Okay, this is non-trivial. Why is this equal? Okay, why is this equal? This is non-trivial. You can see from here. Okay, so we know that along this cuboid, right, I can put my, along this rectangular region, I can put my cuboid. Make sense? Okay, but as you can see, if it is away from this island, what kind of cuboid I put? What kind of cuboid I put away from this island? Do I need to put any cuboid? No, right? Because there's nothing there. Okay, so where should I put my cuboid? Where should I put my cuboid? Inside the island, right? But see, if I have cuboid size like this, okay, you'll see that there's some extra part is not covered, right? So I can put an extra cuboid here. Okay, can or not? So I can put a few cuboid like this, covering a bit more. Okay, but away from this island here, I put nothing because the height of the cuboid should be 0. I define function 0 away from island. Then you should ask, then I cover more than what I need already, right? In this case, correct or not? The total volume of my cuboid cover extra volume than my surface. Correct or not? Okay, so what do? I partition my domain. I make this cuboid smaller, smaller, and smaller, so that I can use smaller and smaller cuboid to estimate the extra region here until all my cuboid stay inside my area volume under the graph. Does it make sense? So imagine the cuboid gets squished until a line. So you have a lot of line or strip below this surface, and then if you join all of them together, then you will get your volume. Make sense? You know what to think about saying? Yeah, you imagine you have a cuboid, okay? Your cuboid get really small and small and small, approximating a point. Okay? Yeah, so you can do this using limit. You cannot use delta x delta y equal to 0 because you put into the product, what you get? 0. You get 0. You double your integral shouldn't be 0, right? Sometimes. Okay, if the volume exists, cannot be 0. But if you take limit, then meaningful number will pop up. Okay or not? So the story here is I use what I know to define what's new. Okay, I use what is known to define what is new. Okay, so to write out the proof is what I described just now, but you need to write it precisely. I think you will see it in MA1, 2 or 1, maybe 2. Okay. Okay, next. So there are a few kinds of general set here. So tag 1 region here is written as below. Okay. So why we call this tag 1? So note that, see this picture here, these 3 pictures here. Okay. So if you fix your A, fix your x coordinate, you can see that your y is changing with respect to x. Okay, your y value is changing with respect to x. Okay. Then, what do you do? So you fix along your x coordinate first, okay, and then you integrate along the y coordinate. Okay, so what do I mean by integrate along y coordinate? So your CD is placed like this. Okay, does it make sense or not? Why I do this? Because my y is controlled by my x. Okay, so I fix one x, I can know all the y I have. I fix one x, I can know all the y I have. Okay, then I will integrate along y first, and then integrate along x, because x is controlled. So there's some weird order here. You know about x, but you integrate x later. You know about x. So wait, let me see. Yeah, so you know about x, and then your y is controlled by x. Okay, so you integrate y first, and then integrate along x. Does it make sense or not? Okay, it makes sense. Why it makes sense in this formula way? Why does it make sense? If you integrate y, you see that your integration domain here depends on x. So your answer will be in x. Then you integrate with x. So your answer will be a number. Okay. Does it make sense? Does it make sense? Okay, if you swap this, then you are compute a different thing already. Okay. Okay or not? Okay. So there's some subtlety here, you see. Although you are integrate with respect to y, but your domain is depend on x. Why? Why? What does this say? Look at this picture here. Look at these 3 pictures here. I fix one x, I can know all the y I have. Because my y is depend on x. Okay. Yeah. Okay. See what time is it? Okay, let's introduce these two types and then we will do example later. So you could imagine the other direction. I know about my y, okay, I fix my y, and then y will tell me the x direction. Okay, so which one I have to integrate first in this case? I need to integrate with respect to x first, okay? Because I can write my x in terms of y, and then I integrate along y. Okay, it makes sense from this formula way, definition way. Why? If I integrate with respect to x, what's the answer I will drop out? My answer will be in terms of y. And then everything is in terms of y, I integrate in terms of y. Then I get the answer. Okay. C and D is a fixed number here. Okay. Does it make sense? So I will say here, so what is happening here? So S is bounded by functions in y. Okay. And then y is bounded by two scalars. Okay. Okay. Any question about these two type region? About these two types. Question? Just ask if you want. Yeah. Never mind. Wrong question also can. Huh? If you confuse, then you ask. Huh? 想不通就是要问。Huh? Confuse 什么 Maybe which point made you think that? I don't know. Which point? Which part? Yeah, which part? 打横 fix y fix y, yeah. This like this, correct? Yes, correct. Yeah, correct. That's right. Yeah, so for this type 2, right, you fix y first, okay? You fix y, and then you integrate along this x direction. You look at the area above it, and then you integrate along y direction. So you add up all your this to get the surface, to get the volume of under the surface. Okay, maybe there's one thing you confuse here. So this bounded part, right, it's just the boundary. Yeah, it's just about the boundary, not about the things inside it. Okay, it's just about the boundary. These are just about the boundary. This function is just about the boundary. But when you integrate along this direction, you'll get everything inside. Okay, and this is what we want for our integral. Okay, we want everything inside the boundary, above here or below, depend on your function. Does it make sense? Make sense or not? And we will see example after break. Okay, let's take a break until 2:04. 2:04. Now what happened to 电路呢？ period. Last what day? Tuesday, we decide our presentation to held in 2 weeks time. Yeah, have you seen the recording? Yeah, yeah. So we have presentation on Friday, 15th, I believe, 15 December. Yeah, it's from 6 p.m. to 8 p.m. You okay? Yeah, Friday. 15, right? Is it 15? Check your calendar. Yeah. Yeah, 15. Okay. So you have to prepare a real life problem that's solved with calculus. So 1 minute to present. And then the other minute you need to answer 2 questions. I put on the course information already. So you need to answer why you okay. So how does maths affect your life? And then the second question is why you choose to study maths in here, exactly. Okay. And then so this part is the same as your written project. So your written project can be submitted on week 15. Okay. So you do presentation first. You just need about 6 slides maximum, I think, because you don't have enough time. You have only 60 seconds. So it's about 10 seconds you can change the slide if you like. Yeah. From past experience, I think the best one is 6 slides to present. Yeah. And then for the project, you need to write down your problem statement. Okay. Tell people clearly what's the real life problem you want to solve. Okay. Just 1 sentence is enough. And then tell people how to solve it using calculus tool. Okay. Yeah. So for all of you, right, please submit your topic latest by next week. Latest by next week.
So the same with everything.
Yeah. What do you mean? Yeah.
Then why solve a problem that is already solved?
Of course. Can. Yeah. Sure. I just want you to phrase it as a problem asking and then problem solving. So last time I showed the balancing stand, right? So maybe you ask the question, how can the 打击的how can the player how can player do the balancing stand? Okay, how they balance the umbrella. Okay, then you use double integral, calculate the center of mass, give you an umbrella. And then where you need to put your leg, where you need to place your umbrella, right? Yeah. I have example on Moodle. You can try and have a look for the past year. Yeah. Mm-hmm. Okay, so another point of this project, right, is for you to independently find subject to learn yourself. Okay, yeah. Of course, you don't understand something, you can come and ask me, but I cannot guide you fully. That's the point. Okay. Does it make sense or not? Yeah. If you found some subject, book, reference you don't understand, then you come and read together with me. I'm okay. But I definitely cannot guide you fully. Okay, because you all have your own thinking. So I don't want to restrict your thinking. Yeah, this is how they practice, at least outside Malaysia. Inside Malaysia, I don't know. Okay. Yeah. So try since first year. Okay, try and develop your own independent thinking. Okay. Then this will be very helpful when you do your FYP. Okay or not? Don't depend too much on your lecturer or supervisor. Okay. Yeah. You can ask, okay, but definitely I cannot guide fully.
And already have 2 of them submit their topic already. Yeah, can think about it already.
中班是拜5的，拜4半夜了。拜5 from M 啊。你在棚里看那个，是他就是。
去哪里？
啊？
去哪里？
光
去哪里？哪里？
哎，你也可以讨论 actually 玩者怎样射的比较准。就是说，
对啊，这都是要配什么东西嘛，对不对？如果换不一样的 hero 要怎样配啊？对不对？
因为你来做主局，然后你老吸血，然后又吸到被同学啊。人家讲谁的装备可以生命最大化
Yeah, maximize, minimize. Okay, okay, I'm ready. Ready to start or not? Ready to start?
Okay, let's start. Let's start. Okay, let's start. Okay, look at this integral here, iterated integral here. Okay. So this integral here, we integrate with respect to what variable first? We integrate with respect to y first. And then we integrate with respect to x. Okay. So we start from the outer variable first, because outer variable is something we can control. So x is from where to where? 3 to 5. Okay, good. 3 to 5. And then how about y? This one is a bit tricky. How to see y here? So as what? Cannot see which one cannot see? Like this. This one. Like this. Okay. Okay. So how to determine your y here? Your y here says what? Depend on x. So let's see. When x equals to 3, what is your lower limit of your y? -3. Okay, so we put a -3 here. How about upper limit? 9. Okay, it's a 9. So here. So you need to integrate along the whole part here. So let me use another color. Okay. Let's try another number. Which one you want to try? 5? Right. Obvious one. Let's try 5. So at 5, what's the lower limit for 1? -5. Okay, let's put -5 in. How about upper limit? 5 times 5. 25. Some 25. Okay, and then you integrate along this. How about the middle one? Okay, let's pick one middle point. Maybe pick 4. What's the limit? What's the lower limit for at 4? -4. Upper limit? 16. So if you do it infinitely many times, what do you get? Actually, for the top part, you will get a graph equals to x squared, and then the bottom one is minus x. Okay, but what you want here is just from x from 3 to 5. So you just want this part. Okay, so this is the area you want to integrate over. Okay or not? Okay, so I will, my practice is to write this domain like minus y, y is from -x to x squared, and then x is controlled from 3 to 5. Like this. Okay, so this is my domain. I will write like this. Okay, now. So if I give you this set of domain, you need to be able to translate to integral. And then if I give you integral, you should be able to find your domain. Okay or not? Yeah. So can you roughly guess what is this surface here? What is this surface here? fxy equals to 4x plus 10y. Or maybe more familiar is z equals to 4x plus 10. This is a plane. Okay, this is a plane. What's the normal vector? 4, 10, and minus 1. Okay, so this is the normal vector, this plane. So you have a plane sitting above, okay, and then you just look at this part here. Okay, and then look at the volume. Okay, so how to do the iterated integral? We just do the normal partial integration. Okay, I think you can compute this. Try and compute this. What do you get? Yeah, try spend 2 minutes, compute this. What do you get? What's the final answer you get? Let me know. Huh? 6. That's all. 6640. Why is different from my answer one? Maybe the other can try and check. My answer is wrong. No, impossible because I computed in 2 ways. Because you see, this CD is placed in vertical way, right? I can place my CD horizontal way. Later we'll talk about this. Try and compute. Check whether you get 6640. Did you integrate correctly or not the function? How do you get? You finish? How do you get? Hmm. 2024 over 3, like this. Different from mine also. If we use the same number. Yeah. I computed 2 ways. Let's check another one, another answer. You check already? You double check? Ethan? Yeah. How about one more answer from the others? See what you get. This is just one variable integration, so please be careful when you compute. Sorry, what did you say? 3, 3, 2, 5, 6. That's all. No. 1, 3 different answers. Larry finish. 3720. Wow, 3720. Say again. These first 3 same to my answer. Okay. Wait, first, you first, Ivan. 101. Yes, this one is my answer. Yeah. 1, 2, 3, 4, 5, 6. The 6 answers. So. Yeah, this is so interesting. How you guys get so many different answers? Check which part you did the calculation wrong. Okay. So many different answers. Check which part you goes wrong. Yeah, good. So I will take the right answer. Okay or not? Can you guys pick up your mistake? Very often you will get mistake in your iterated integral. And this one is counted easier because this is just a polynomial. If there's more trigonometry, that's very harder. Okay. Okay or not? Okay, please check your solution. Okay, so I said that I use 2 ways to compute this answer here. So what's the other way I can compute this? I can do dx dy. So I fix my y direction, and then I find my area bounded by in terms of y. Okay, my x bounded by my y. So can you guess? Can you guess how do you cut this into? How do you cut this using x direction? How do you cut this? Yeah, how do you cut this? If I try to compute, let's say, integrate 4x plus 10y dx dy. Okay, so I fix my y direction. And then I integrate along the x direction. So I place my CD on the other direction. Can you imagine how you do this? So in this case here, you need to describe the curve in terms of what? Okay, you need to describe your. So if you fix one y, you need to tell me the lower bound and the upper bound. Okay, lower bound and the upper bound. So the upper bound is easy, right? See, where's the upper bound here? It's just x equals to 5. Okay, but the lower bound here changed. Okay, the lower bound here changed, but fix again here, and then change again. But how to change? You already know, right? So this part is what? This part is y equals to x squared. So meaning x equals to square root 1. Okay, how about bottom here? You know that this part is y equals to minus x, so x equals to minus 5. Okay, so basically you split them into 3 parts here. Okay, and then you can do this integral. I think this one is much harder. I mean, more steps at least. Okay, so really depend on the order you pick here. If you pick the other order, then you will jump into the sea of calculation. Okay, yeah, but as an exercise, you can try. Okay, as an exercise, you should try. You can see which one better. In case you jump into the sea of calculation, you still know how to swim. Okay, you don't give up. You surely will get some answer, but sometimes a bit dangerous. Maybe you need some trigo integration sometimes. Some very hard integral. Although it's polynomial, like square root 1 plus x squared, something like that. Then you need to jump into trigo stuff. Okay, but if you use the other direction, then you can avoid these things. Okay. Yeah. All right. So I'll post this. You can try it out, or you can read later. And how about let's try a few more examples. Okay, I'll let you try this. Yeah, let you try. So I'll try and spend 3 minutes, see what you can get. So you need to make some choice here. No choice is correct or wrong. It's just hard or easy. Okay, and you need to learn to make choice. Yeah, choose your favorite CD placement. Okay. Okay. You can stop for a while, see we have the same method or not. Okay, so so in the exam, right, maybe you are not given, you most probably not given this shape here. Okay, you need to produce this shape yourself. Okay or not? So you need to know how to draw this basic graph. Then there's the point where you need to find the intersection. Yeah, it's like the polar curve intersection. How do you find this intersection here? Right? You just map the two curve meet. Okay, make the two curve meet. Okay, and then you find where they meet. Okay, and then you sub the values into either of the curve, because if they intersect, these intersection point must live on both curves. Okay, you just sub into either one of them, you'll get the answer. Okay, so which direction you want to pick? dy dx or dx dy? Dy dx. Okay, so we'll pick dy dx here. So let's turn this into domain first. This is very useful because later when you want to do the vector calculus. Okay, so let's do this domain, integration domain. So we integrate y. So if I want to do dy dx, so meaning I fix my x first. Okay, let's fix our x first. So our x is going from -1 to 1. Okay, and then my y is going from 0. Not 0, right? So it's bounded. So you need to determine which one is lower, which one is higher. Okay. So you first plot the 2x squared and then 1 plus x squared. So because x squared shifted up by 1, so this one is higher. So bounded below by 2x squared, bounded above by 1 plus x squared. Okay, you need to write this domain out. Then your double integral here will be easy. Okay. So my double integral here will become integrating from -1 to 1 to x squared 1 plus x squared times x plus 2y dy dx. Okay, then you do this integral. Any one of you finish or not this integral? Finish. What do you get? 32 over 15. Okay, good. So do this iterated integral here. You get 32 over 15. Any others finish calculation but you don't get 32 over 15? Huh? Zongi got finish or not? Same, huh? Okay, good. Same. Yeah, good. Same. Because these are polynomials, so should be quite easy. If there's a square root involved, then you maybe want to cry. Okay. Okay or not? Any one of you try dx dy or not? Dx dy. Have you guys tried dx dy? So you fix the y direction and then you see how your x get bounded. You see, if your y is above here, right? There are two parts of x here. See? Right. Okay. And then until here, then you can join up these two. Okay. You can try. It's kind of interesting. A bit tedious, no? Just a bit tedious. Huh? How? So if I do dx dy, so meaning I fix the outer one first, dy. So along y, right, at the top here, you'll see that your x split into two parts. Okay, only when when your y is equals to 1 here, then this part will join up. Okay, so it means that these two parts have different description. Is it correct or not? Yes, correct. Because here is y equals to 2x squared. So meaning your x was split into y over 2 square root plus minus square root. Okay, so plus part is here. Then the minus part is here. Yeah, so you need to do some change of variable, something like that. So here is the calculation. Yeah. So here is the calculation. You will get the same answer. You can try it yourself, okay? I'll post this up. If you want to look, also can. But I want to tell you, you just read and you work on it is different story. Okay or not? Once you do hands-on, this is your experience. If you read, it just remain a memory. Okay. If you forgot this, then you won't write it down again. But if you practice, then you will gain the experience. You'll know what to do, where I make mistake, how to correct the mistake. Okay or not? So these are two different stories. These are. Okay. Any question about this? Any question or not? Does everyone know what to do if you want to swap variable? Okay. Sing. Make sure you listen. I don't want to see you crying during exam. Okay or not? Now rather than cry later. Okay. Okay. I like your positivity. Okay. Please keep it. Okay. Let's skip these questions. You can do it at home, or we will do it as a exercise when we start next lecture. Okay. Kind of boring. Keep doing the same thing. Right. Okay. Let's do this one. How about do this one? Okay. The last one. Do this one. This one gets some have some moral story here. So let's do this. Try and do this. Okay, try and do this. I skip a lot. Who say that? Hanwei, huh? Yeah, you try and do this as a homework, or next time I will pick one or few of them as an exercise to revise. Okay. Yeah, and we try this one more. Okay, we try one of this. 1, 2, 3. Okay, these two. I will pick few of them as an exercise next lecture so that we can remind ourselves again. Okay, try and do this. Why this question asks you to reverse the order? Try. If you don't reverse the order, can you do it? Okay. You will manage to try this? No problem. Is that? Okay, okay. Okay, manage to reverse this order or not? Can you straight away just reverse it? Can you just straight away reverse the order? Can you just straight away swap your integration domain or not? If you just swap it, then your x plus x over 2 will go to the outside. Okay. Then you will get something in terms of function, which is not what we want. We want to get some value out of it. Okay. So meaning what? If I change the order, we need to change our way to describe the domain here. Okay. So how do you describe? So first, let's determine what are they doing here. So what is dy dx? So meaning you fix your x direction first, and then you integrate along y direction. Okay. So meaning when you fix one x, okay, from 0 to 4, your y is changing from x over 2 to 2. Okay. So meaning what? Let's say I fix here 0. Okay. Then my y is going from 0 to 2. Okay. So it's along this line. So maybe use that. Okay. Yeah. See, when I want to integrate at x equals to 2, where is my y going from? Where to where? Y is going from where to where? Oh. Here. X over 2 to 2. So when x equals to 2, what happened? 1 to 2, 2. Okay. So we are integrating the surface like this. So if we want to change our order, we need to place our CD on the other direction. Okay. So meaning what? We need to fix my y direction first. So what's my y direction now? From where to where? My y direction is from where to where? Okay. Yeah. My good note James. And let me try again. Wait bad not. One good note becomes 6, I become bad. Okay. So we need to fix our y first. So y going from where to where? 0 to 2. Okay. My y is going from 0 to 2, right? 0 to 2. Then how does my x depend on y? So you need to find what's the lower limit, what is the upper limit. Okay. Right. So along this x direction. So what is my lower limit here? 0, right? 0, this is the 0 line. And then what is my upper limit? So this line, what is this line? This is at first y equals to x over 2. So depend on y, it becomes 2 to y. Okay, so this is equivalent to the line x equals to 2y. Okay or not? So bounded above by this line, bounded below by this line. Okay, so now you are ready to change your order because you already got your domain. So you are ready to change your order now. Okay, so you're ready to change your order and change it to from 0 to 2, 0 to 2y, e to the y squared, dx, dy. Okay, and then you integrate with respect to x. There's nothing about x here. So you just integrate over a constant. So you get x times e to the y squared from 0 to 2y. Then you will get 2y e y squared dy. How to integrate this expression here? You know how to integrate this? How to integrate this? What? Minus y. What technique you use? What technique you use to integrate this? substitution. Okay, you can use integration by substitution. Du equals to 2y. Okay, then what happened to your new integration domain here? So it becomes 0 and f4. So this becomes du, which is e to the u 40, which is e to the 4 minus 1. Okay. Yeah, so why the question asks you to do this? Can you straight away integrate this term or not? Can we integrate this term here? E to the y squared without substitution. How to do this integration? Can you do this or not? I don't know. Not on top of my head. Not the usual integration technique. Not by part, not substitution. Okay. But later, so later we will learn something similar. So later we will solve this. Did you guys do this in your probability or not? Did the teacher find the integral for you? Find the integral for you? Or just show you what is it equal to? Just show, huh? Doesn't show, huh? Still remember the answer. Huh? This answer is square root pi, I think. Yeah. We will prove this later. Okay, we will prove this later. Okay, for finite one, I'm not sure. I only know how to find the infinity to minus infinity. Okay, I will show this later. Later in the course. Okay. Okay. All right. So let's keep continue. Yeah, let's keep continue. So for the 3 example I skip, you can try it at home if you would like, or I will give you exercise next lecture at the start of the next lecture to remind you. Okay, so let's keep going. So properties of a double integral. So if you are integrating over 2 regions that don't overlap except the boundary, you can split the integral. Okay, this is what we have been doing already. Okay, when we integrate the piecewise function, we just split the integral into piecewise function. And then, if we integrate over the area 1, what do we get? If we integrate over the constant 1, what do we get? The height is 1. Actually, what we get is the area of the domain. Okay, area of the domain we integrate over. Why? Why? Think about it. So if you have a box, okay, with area L times H, but the height is 1 meter. So how about I pick L and W? But the height is just 1 meter. What's the volume? The volume of this box is L times W times 1 meters cubed, let's say. What's the area? Area of the top. It is also L times W. Okay, the unit is different, but they are the same because you are multiplied by height 1. Anything, any numbers times 1 is just the number. Okay, 1 is the identity, in other words. Next, if your function, okay, is bounded by 2 constants here, okay, then this means what? That means your double integral is also bounded by the 2 function multiplied by the area of your domain. Okay. So here's the picture here. Okay, here is the picture. So your Z is some surface like this. You can bound above and below by some constant. And then your integral should be bounded in the middle of these 2 volume here. Okay. Yeah. So this means what? This means the double integral respect the order. Okay. I think we have seen this last time. Double integral respect the order. Okay. Okay or not? Do you know how to get this inequality from part 2? Do you know how to get this inequality from part 2? Yeah. Right. So what? So you have this inequality, right? Okay. But we know that, what do we know? We know that double integral respect the order. So we can do double integral on 3 of them. Okay. But integrate over a constant, what do you get? Last time we talked about this. Integrate over the constant, what do you get? You can just pull out the constant. Okay. And then this is integrate over 1 dA. Okay. And then what is this? Just now we say that integrate over 1, what do you get? You just get area of the domain. That's why we get m times area of the this. Okay. Okay. Similarly, for the right hand side here, you get m times a times. Okay. Hey, that's very important thing here. You see, here's the domain. Here's dA. What does this dA means? What does this dA means? What does the dA means? Delta A. So meaning what? Change in area. Small change in area. Okay. Typically, we write this dA using dx dy just now. So what's change in area? So you want to change in area, meaning you want to change in two sides, dx in the x direction and in the y direction. But this is in a rectangular coordinate. In different coordinate, we will have different change. Okay, later we'll learn polar coordinate, how to integrate over polar coordinate. Okay, so this A here will be depending on what coordinate you use. The coordinate we use now is x and y. So it is dx times dy. Okay. Okay. Right. So how about try this here? So let's try this. So let's see how we use the property. So estimate this integral where this is the, so the d is the disk with center at origin with radius 2. So let's do it. So let's draw our d first. So our d is a disk with a center at the origin with radius 2. Okay, so this is our domain picture here. Okay, so how to estimate this? Okay, how to estimate this function here? How to estimate this integral? So to estimate this integral, we need to start with estimating the function. Okay, how do we estimate this function here? Anything we can bound this function on. Sin s cos y. So sine function is bounded by what? -1 and 1. Okay, we can do -1 and 1. Bounding sin x cos y. Okay. Because both of them are in between -1 and 1, so you multiply them together, the values you will get is still within -1 and 1. Okay. From here, okay, we will get that e to the sin x cos y is bounded by e minus 1 and e. Why can we write like this? Why can we do this? Continuous? No, not just continuous. Huh? Correct. So most importantly is monotonely increasing. I think, yeah, monotonely increasing. Yeah. Okay. So when you have increasing x value here, okay, your y is increasing as well.
Okay, you should think of this as a e to the x. I mean e to the z. Okay, the z is bounded by -1 to 1. Okay, and then in this region here, e is increasing. So you respect the order here. Okay or not? Okay. This one very important when you go into later course. You cannot just apply straight apply like that. Okay, so yeah, because the inequality might change depend on your function. Okay, so if your function is decreasing, then this will change. This inequality here will change. Okay, so we have bound on my function now. Okay, I bound on my function now. So how can I estimate my integral? Okay, so just now the the third property here tells us that this inequality here is bounded below by e to the -1 times the area of this bounded above by e to the times area multiply area of this. Okay, so what's the area of this here? Pi r squared. Okay, the radius of this is 2, so you get 4 pi. Okay, so this integral here is bounded by 4 pi divided by e, bounded below by this number, and then bounded above by 4 pi e. Okay, yeah. Maybe for this question, right, you can find either even smaller bound, but that's okay. Okay, yeah. It's just some estimation. Okay, we have a little time. Okay, just little time to introduce this, and then we will stop. So double integral in polar coordinate. Okay, so how to do double integral in polar coordinate? So you should think of the pizza story here, or you eat. Do you guys eat McDonald's? Is it McDonald's? Okay, not McDonald's. McDonald's don't have this. No. I want to talk about the pineapple slice. Pineapple slice. So if you go to the LY3, there's a store selling burger, right? So they like to put the pineapple slice there. The pineapple slice is the one with a hole in the middle, right? Okay. So this is the polar rectangle. Okay, that's the general picture for this polar rectangle here. So remember, polar is controlled by how many variables? 2. One is radius, one is angle. Okay, so you can go along with radius, okay, and then you can go along with angle. Okay or not? Okay, so let's say this rectangle here is bounded, the radius is bounded by A and B. Okay, so you have A direction, A radius, and then B radius. Okay, and then your angle is from alpha to beta. Then you will slice out this pineapple slice here. Does it make sense? Make sense or not? So you no longer draw your area and the bounded area in the vertical form, right? All of it is respecting your origin. Okay. Does it make sense? Yeah. Maybe we start with this polar rectangle. Any question or no on this? How to read this polar rectangle? Does it make sense about this polar rectangle? So you fix your radius, you swipe out part of the circle, right? You fix a radius, you swipe out part of the circle. Okay. And then you look at all the area bounded by these two pieces of arc of two arcs of circle. Okay, 2 arcs of 2 circles. Arc of 2 circles. Okay, then you look at the area between these two circles here. And then you will get your polar rectangle. Okay, so polar rectangle also can look like this. Full this, there's no hole here. Also valid. This means what? This means you start with a radius 0. 0 to some alpha maybe. So maybe let's call it A here. A. And then your angle is going from 0 to sorry? Rectangle, yeah. Polar rectangle. Yeah. Circle is a polar rectangle, yeah, correct. Yeah, true. Yeah, true, very true. Yeah. Yeah. You can think like that. You can think like that. Yeah. Yeah, you can use this polar rectangle to do funny stuff. What do you mean by checkerboard? Make your checkerboard into polar. I don't get it. What do you mean? So you want to make the board into polar? Is it? That's my question. You can try. You could try. You could try. Right. So maybe you can use this polar rectangle to draw the Tower of Pisa. You know what's the Tower of Pisa? Pisa 斜塔. Now you can talk about Pisa, Tower of Pisa. Why it can stay for so long? Okay.